it's me Devendra. Today I'm gonna show you and describe some of the basic principles that are used in the bridge rectifier, how we use it in the amplification, and I am also gonna describe you the circuit diagram of bridge rectifier with input and output voltage in bridge rectifier along with filter circuit. Now all I have got is a voltage regulator here. Here you can see a simple multimeter for measuring the AC and DC output voltages and the currents. Now I've got here is a step of transformer that I am gonna illustrate it for more use in the basic and more important purposes. There is a MCB here. There is a battery supply. Now all I have got is a heating iron. This one is for welding purposes, and I have got is a solder. You bridge rectifier with a filter circuit. Basically in a filter circuit, okay, a resistor RL. This one is a resistor, say RL. Now all the principle that it is working is like that of a voltage regulator. Anyway, this one is for rectification purpose, and this one is a transformer. Okay, this one is a transformer. Now I will insert diode here. I will say a diode, one here, another diode here. Okay, this is another diode parallel to this line in this direction, and finally we'll get a diode heading in the right direction. Okay, now all the principle that works in a full wave rectifier with the filter circuit is like that I've described here. Finally, after the completion of the circuit, after application of a sinusoidal AC from the circuit, we'll finally get a steady current DC. Okay, now if we talk about this, I will give you the representation of how it will convert into a DC circuit. Okay, this one is a DC circuit. Sorry, DC current. Now all I have done is to represent some of the arrow lines. Right, here it will go, here it will go, it will then pass to this diode, finally to this diode. This one is a rectifier circuit. Now it all works on like this principle when it goes from here, and now in a resistor we will get the resisting. Okay, now here is the full circuit diagram for the bridge rectifier. This one is a bridge rectifier with a filter circuit. Okay, bridge rectifier with a filter circuit. Now I'm gonna describe you the theoretical portion. How does it works? How it really converts and accumulate the current into the DC, make it a conversion so that we can utilize on it on any types of electronic devices that we are using. Okay, now all I've got is a transformer here. I've got a capacitor here. Anyway, in this project I'm not gonna show you the big application of this rectifier. I will illustrate it in a small project now. Okay, I'm gonna describe you the theory. How does it convert the AC into DC and provides a regular supply so that we can conduct it on any types of devices. Now this circuit converts full cycle of AC into DC as I shown in figure. Okay, this shows the circuit diagram of a bridge rectifier. Now in our real life it consists of 4 diodes D1, D2, D3 and D4 arranged in the form of a Wheatstone bridge network. The input AC is applied across the primary of the transformer. Okay, when the ends of the terminals of the secondary are connected to the 2 opposite ends and C of the network. Now okay, and C of the network. Now during the positive half cycle, and the remaining ends B and D of the networks are connected to the load resistor R. I have shown it here. Now during the positive half cycle of the secondary voltage, one end of the secondary, okay, I will give it a name. Okay, this one is a say A becomes positive and C becomes negative. Okay, now I will say it C. Okay, C becomes negative. Okay, diodes. Okay, these diodes are D1 and D3 are forward biased, and that means I have given you the name. I forget it to write here. Okay, these diode D1 and D3 are forward biased as they conduct the current. The current flows in the directions. Okay, and at the same time, okay, these diodes when get biased, the current will flow in the direction like I will show you how it flows in the direction. It will go to this circuit. Okay, this goes to from this point goes to here, then it will goes to the circuit to the that point. Now this will go to the circuit of the load resistor, and at the same time the diodes remaining, that I will say it, okay, I will say that diodes, say D4 and say it is D2, these are non-conducting since they are reverse bias. And another way, in the next half cycle the in A is negative and C is positive, that's D2 and D4 conduct, but that's D1 and D2 do not conduct. The current similarly flows in the direction, as I will represent you how it flows. It flows in the direction like this. This goes to there, this goes to there, okay. And now from this point, okay, it will travel through this point, okay, and now it will travel to the load resistor RL in the same direction. In this way the bridge rectifier acts as a full wave rectifier. The wave that is generated finally from this rectifier will be like this. This one is a sinusoidal AC, okay, this one is a sinusoidal AC, this one is the output. This output comes in like this, okay, when it goes, okay, I'm sorry, now we will get a line from these points, okay. It will be like this, this, this and this, okay. Now these are the diodes that are D1, D3, D2, D4, D1, D3, D2, D4, and so on. Now this one is a voltage, I say P in. This is a time response with frequency and time. Now there is O, this one is P out, and this one is again omega T. Now this is pi, 2 pi, 3 pi, 4 pi. Anyway, in this way a full wave bridge rectifier works. If we talk about the filter circuit, the output of a rectifier is pulsating DC, which contains DC and AC components. The presence of an AC component is most undesirable in most of the cases. So therefore we must there must be the removal of the rectifier output. To get steady voltage with minimum ripple, a circuit is connected between the rectifier and the load. Okay, this one is a rectifier, this one is a load. This circuit which is connected between rectifier and the load to convert the pulsating DC output rectifier to steady DC is known as a filter circuit that I have described it here. So filter circuit available in the market. Some of the commonly named filter circuits are the inductor filter, capacitor filter, LC filter, pi filter. Okay, this whole filter works on the principle that we have to convert a pulsating DC into a steady DC. So that in general, if you want to know the basic principle that is used in a filter circuit, I will show you a simple theoretical concept. In a filter circuit, when you get a DC like this, okay, now I will apply a filter circuit. Now when we pass a filter circuit, if this one is a filter circuit, it will finally convert it into a steady, okay, output with filter, convert it into a steady DC. This one is B naught, I say. This one is a output voltage. This figure gives the concept of the filter circuit. The filter circuit consists of passive elements like inductor, capacitor, resistor, and the combination that I have already talked about, the characterization of the filter circuit. The filtering action depends upon the basic electrical properties of these passive elements. As we know about the inductance, XL is equal to 2 pi FL, XC is equal to 1 by 2 pi FC, XL is equal to 0, okay, XL is equal to 0, F is equal to 0 for DC. Okay, for DC we take is about XL is equal to 2 pi FL, XC is equal to 1 by 2 pi FC. There are the impedance, inductance that we always talk about in the field of electricity and magnetism. Now then XL is equal to 0 and XC is equal to infinity. Okay, XL is equal to 0 and XC is equal to infinity. That is really defined by the theoretical concept. Okay, that is just for the direct current circuit. This shows that the inductor offers a low resistance and capacitor offers infinite or high resistance for DC. It means that the capacitor allows the AC to pass through, but it blocks the DC, and inductor allows DC to pass through it, but blocks the AC. Some of the commonly used filter circuits are inductor filter, capacitor, LC filter, and pi filter that works on this type of principle. Now I will show you practically how we conduct it. I have made a bridge rectifier with a filter circuit. This one is a capacitor. These are the 4 diodes which are connected in the Wheatstone bridge that I have already talked about theoretically. This one is for the adjustment of the voltage. This one is for reversing the, and also for the reversing the supply if they are in opposite direction. Now this one is a transformer. I will show you how carefully and how cautiously, so that we can convert it into AC into DC and make a simple touch light. Okay, this one is a transformer. I have connected it in the primary winding, and now you can see here are the secondary winding wires. All the thing that you have to be careful in connecting these wires to the diode is that here I have also put a resistor R. You can see this. Okay, this one is a resistor capacitor filter circuit. Now here you have to be careful in joining the wire. Now I will reverse it. Now in this